All right, guys, so you had to do 16 through 30 over the weekend for homework, so this is just your little answer key here. The answer was choice E as an excellent. So if you didn't get choice E, then I think you should watch this question and watch the video and make sure you understand it. If you did get choice E and you didn't guess, then you can skip ahead and go to number 17. Okay, but it does ask for the acceleration, and it did give you the position, right? So if it gives you the position, we want the acceleration, we're going to take the second derivative. So I'm going to start by finding the velocity, which is the first derivative. So the velocity is equal to, and I'm going to do low d high. So low d high, which is -1, minus high d low. Now, the derivative of the low is just 1, so I'm not going to write it if that's all right with you. And then it's going to be over low, that quantity squared. Okay, I would probably suggest before you go and start taking the second derivative, let's kind of simplify this first derivative first. So, velocity would equal, now I'm going to distribute the -1 here through to everything I see here, okay? So then that's going to end up giving me a -t minus a 1. And then I'm going to take the negative or the minus sign right here, and I'm going to distribute that through everything there. And that's going to give me a -1 and a positive t. And again, the denominator is going to be over 1 plus t, that quantity squared. So when you look at that, you're going to see that your t's are going to cancel out. So that's gone and that's gone. Okay? And then that's just going to leave you with, in the numerator, a -2, and in the denominator, 1 plus t, that quantity squared. Okay, so there's the velocity. Let's go one more, and we're going to do the acceleration, which is the derivative of that. So I'm going to do low d high. Now the derivative of the high is 0, though. Okay, so we know that that's really all just going to cancel out. Minus high d low. All right, so we got to do a little bit of chain rule here. So I have 2 times 1 plus t, that's technically to the first power. And then don't forget that technically you're supposed to take the derivative of what's inside here, but the derivative of that is just a 1, so if you're good, I'm just not going to write that. Okay, and then I'm going to close that out. And then this is all over low squared. So now that 1 plus t, that quantity squared, is going to become to the 4th power. All right, now I have to plug in 0 here. Well, if you want, let's just plug it in right now. It doesn't really matter whether we simplify now or not. What I am going to do, though, if you're good with this, I'm just going to make these guys right here, I'm going to multiply those. So that's going to be a positive 4. Okay, so that's going to give me 4. And then I have 1 plus t, now remember t is 0 though, all over 1 plus t is 0 again, to the 4th power. So that's 4 in the numerator, 1 in the denominator, so that's for choice E. All right, for number 17, I know we did this one in class, so I'm going to skip this one, but remember that the answer is choice C. Look at your notes from what we did in class. 18, we also did that one in class. So again, I'm going to skip over the explanation because we went through that, and that is choice C. All right, no cheating on this question. You should know that this is an upward pointing parabola, right? Because the x-squared is positive. However, you may not know exactly where I have a turning point or anything like that. And yes, it would be so much easier if we could just plug this into our calculator, but we can't because it's a non-calculator question. So my suggestion is start with the number 0, plug in 0 here, and you'll see you'll get 2. Then plug in 1 here, and you see that you will get 1. And then plug in 2, 3, 4, 5, and 6, all the way up to 6. Okay, I think that's the way that I would go about doing that. So let me draw you just a little picture of what I ended up getting. So at 0, I was at 2. Okay, that's 0, 2. And then at 1, I went down to 1. and then at x equals 2, I was back up at 2. And then when I got to x equals, here, I should probably do that for you, right? 4. Now remember, it doesn't have to be the beautiful graph. We just need to understand the basic concept. When I plugged in 4, I got a y value of 10. And I'll show you why I'm not putting every single point on here. Okay. So if you read the question, it says that the integral, in other words, the area under the curve from 0 to 6, is approximated by 3 inscribed rectangles, equal width on the x-axis. So if I'm going from 0 to 6, then each of my rectangles is going to be 2 wide. Watch, I'm going to have 1, 2, 3 rectangles. Now, inscribed means that they need to stay underneath the curve. Okay, so my first rectangle here that goes from 0 to 2 has to stay under the curve. So its maximum height can't be higher than 1. So in other words, just in case you're not following me here, it would have to look, oops, that is so bad. It would have to look like that. I'm going to shade that in so you can see it. Okay, do you see that that stays under the curve? Now, so that's really a midpoint Riemann sum, by the way. Not that it matters, but just explaining. Okay, so now we're going to go from 2 to 4. And again, I have to stay under the curve. So that means I'm going to go to x equals 2, and I'm going to go up to its height, which is up at 2, and over. And that will keep that rectangle underneath the curve. Okay, so I'm going to start at 2, go up, over, down. And there's my second rectangle. Then, to stay under the curve from 4 to 6, I'm going to do the same thing. I'm going to start at 4, go up, over, and down. And that's why I didn't need to find the height at x equals 5 or the height at x equals 6. So if you look at those 3 rectangles, 1, 2, 3, all of them stay underneath the curve, and that's what inscribed means, that you have to stay underneath that curve. All right, so we just want an approximate area, right? So I'm going to take the area of that first rectangle, and I know that its width is 2, and I know that its height is 1. Then the second rectangle, I know that its width is 2. Its height, however, is 2. Plus, then the third rectangle, its width is 2, and its height is 10. So I've got 2 plus 4 plus 20 equals 26. So the answer is choice B. All right, this will be a quick one. The answer is choice E. Now, reason being, just to show you quickly, if you follow going all the way across, do you see all of these slopes are always the same, which means it has to be a function of y. So it means that the equation can only have a y in it. Well, this has an x in it, so does this, so does this, and so does this. So the only one it can be is choice E. Okay, for 21, the answer is E, as an excellent. Reason being, here it tells you the derivative is less than 0. And just remember, if the derivative is less than 0, that means that the function is decreasing. Okay, and then if you look at the next bit of information that they give you, they tell you that the second derivative is greater than 0. And what that means is the function is concave up. So I'm looking for the picture that's decreasing, concave up. And as much as C is decreasing the whole time, do you see here it goes from concave up to concave down, so that can't be it. This guy's increasing all the time, so is this guy, so is this guy. But this one is decreasing, concave up. Okay, so answer choice C. All right, so they gave you the first derivative and they want you to take the second derivative. So basically I'm going to do product rule. So I'm going to take the first times the derivative of the second, which is 2y, dy dx, plus, then we're going to do the second, which is y squared, times the derivative of the first, which is 2x. Technically dx dx, but remember we don't have to write that. All right, the only little issue that I have here is this dy dx. Now, it's really not that much of an issue really because we know what dy dx is. They gave it to us. So on my next step down, all I'm going to do is I'm just going to write that this is x squared times 2y times x squared y squared. So I just replaced that dy dx with x squared y squared. Plus, and I'm just going to rearrange this a little bit, 2xy squared. Okay, and oh, I probably should have started with the answer is E. So if you did get this right, you don't have to listen to me anymore. But anyway, so now I'm going to keep going. If you didn't get it right, pay attention. All right, so I'm going to put the 2 in front, and I have, actually, if I look here, I have an x squared and another x squared, right? So that's going to give me x to the 4th. And then if I look again, I have got a y and a y squared, so that's going to give me y cubed, right? Y cubed plus 2xy squared, and there is your answer. All right, my advice to you on this one is I would split this integral up. So like this, I would say, let me simplify that, and then let me simplify that and make it 2 separate integrals. So remember, I always like to keep the constant on the outside. Okay, whoops. All right, so I am integrating from what? 1 to e squared. Okay, so if I take, let me see here, if I take that x and that x squared, do you see that that's going to become 1 over x, right? Or I could say dx over x. Okay, and since there's a minus sign in between them, I'm going to put minus, and then I'm going to integrate again from 1 to e squared, and then I'm going to look at x cubed and x squared, and I'm going to reduce that, and that's one's pretty easy. That's just going to be x dx. All right, so if we look at the first integral, I'm going to just bring that 4 down, and actually let me just open up a set of brackets for giggles. Dx over x, okay, remember that that's an ln. So we have the ln of x, and we're going to evaluate that from 1 to e squared, minus, and then I have the integral of x, which is 1/2 x squared, right? So 1/2 x squared, and that's going to be from 1 to e squared. All right, now I am going to go like this and like this, if that's okay with you, because I like to keep that 1/2 on the outside. Okay, let's just keep the 4 out of it for now. We'll deal with it later. So I have the ln of e squared. I'll deal with that in a minute, minus the ln of 1. So that's from the first integral, right? Minus 1/2. And then I have e squared squared, which is e to the 4th, minus, and then 1. Okay? All right, well, remember, you have an ln and an e. Those cancel each other out, and then this 2 will just drop down, and so it's just going to become a plain old regular 2. So I'm going to have 4 times, and then I've got 2 minus, and the ln of 1 is 0, so really that's just 2. Let me throw in those brackets there. Okay, minus 1/2. And, well, I can't tell you much on that e to the 4th, so let's just bring it through. How about I do this? How about I just take this exponent, or this fraction here, and let's just distribute it through, okay? So that's going to give me 1/2 e to the 4th, and that's going to be plus 1/2, right? Negative times a negative, plus 1/2. Okay, equals, let's keep going. So I've got 4, then I've got 2 minus 1/2 e to the 4th plus 1/2. Okay, well, 2 plus 1/2 is 5/2, right? Minus 1/2 e to the 4th. And then I'm multiplying that all by 4. So that's going to give me 10 minus 2 e to the 4th. And the answer then is choice E. Okay, the answer to this question is choice C. No offense, I don't know that many of you will have gotten that. Maybe you did, and that's awesome if you did. We haven't done a question like this, but actually they're really not that hard. Watch. So they're giving you h of x, right? And they want h prime of 3. So I'm going to just start with finding, obviously, just h prime of x. So I'm going to do product rules. So I'm going to take the first times the derivative of the second plus the second times the derivative of the first. And then they want me to throw in 3, right? Okay, so this isn't so bad, I promise. So I'm going to be looking for f of 3, g prime of 3. I'm going to be looking for g of 3 and f prime of 3. Okay. So listen, if you look at this, it specifically states that these are the graphs of the function. So to find f of 3, now here's my f graph right here. I'm going to go to where it's 3. There it is. So f of 3 is 1. Easy enough, right? So let me just throw in a 1 right here. Now I'm going to skip to g of 3. Okay, so g of 3. Well, this is the graph of g. I'm going to go to where x equals 3. Here it is, right? That's x equals 3. And look at its y value. That's positive 3. So then I know that that is 3. Okay, now as far as the derivatives, remember derivative, Aiden said it the other day in class, derivative means slope. So if I'm looking for g prime of 3, all I'm going to do is I'm going to take my g prime graph, which is right here, right? And at x equals 3, here we go, what's the slope here? And if I look, that's up 1 over 1, up 1 over 1. So the slope at 3 is 1. And then you're going to do the same for f at x equals 3. So let's just go here. Here's my f graph at x equals 3. Let's find the slope. So that's down 1 over 1, 2, 3. Okay, so you'll see that that is a negative 1 over 3. So negative 1/3 is that slope. So then we just simply put in negative 1/3 right here. See, that's not so bad, right? You're all whining and crying, I know. So then that's going to be minus 1. And then that answer is 0. So your answer is choice C. Now, we want to be a little careful here. By the way, the answer is D as in dog. But let's look at this and let's notice that they're having us go from -2 to +1. And if you notice that this part of the piecewise function deals with the negative numbers. So what I'm going to do is I have to break this integral up into 2 separate integrals. Okay, so if you're not totally following me, hold on a second. So just watch for a second. So what if I did this? If I did an integral from -2, and the reason I'm starting at -2 is because this is starting at -2. Okay, and I'm going to go up to 0. And the only reason why I'm going up to 0 is because this part of the piecewise function would encompass the values of -2 all the way up to 0 because we're including 0 here. So then if I'm going from -2 to 0, I'm basically going to be integrating this part of the piecewise function. So then I'm going to write x dx. Okay? All right, plus now I need to form another integral because it wants me to go all the way up to 1. So then I'm going to go from 0 to 1, and then, let me just explain, okay? This domain encompasses 0 to 1. So I'm going to use this part of the piecewise function down here. Okay, so then I'm going to put x plus 1 here, right? X plus 1 dx. All right, now I left a little something out, didn't I? I don't know if you realize that or not, but there was an x in front of all of this. So each of these guys should have an x here and an x here. Okay, so let me just put that in. I'm going to put it in a different color so you can see it. Okay, so x and then x. Okay, so again, this is the part of the piecewise function that contained the negative x values. And then this right here was the part of the piecewise function that contained the positive x values. And that's why I split this integral up into two separate integrals. So now basically what I'm doing is, I know how much you love integration, we're going to actually do it twice. Haha. So if we're going to do it twice though, let's do this. Let's simplify it just a little bit before we start doing that. Okay, so essentially from -2 to 0, I'm going to be integrating x squared. And when I'm integrating from 0 to 1, I'm going to be integrating what? X squared plus x, right? dx. Okay, I don't know if I said what the answer was. I think I did, but the answer is D, as in dog. Yeah, I think I did. But all right, so I have 1/3 x cubed, and we're going to evaluate this from -1 to 0. We'll deal with that in a minute. And actually, let me stick that in like that. You know how I like to do that. Okay, plus, and then I'm going to have 1/3 x cubed again. And this is going to be plus 1/2 x squared, right? And we are going to evaluate that from 0 to 1. Okay, so let's see what I get here. So here I am going to get, well, if I put in 0 first, which is what I'm supposed to do, aren't I going to get 0 minus, and I'm going to bring that 1/3 through, and then when I put in -1 and I cube that, that's going to be, oh my gosh, that's not -1. That's -2, isn't it? My mistake. I can't read my own handwriting. That was supposed to be a 2 there. I'm so sorry. Okay, so then if I plug in -2 and I cube it, that's going to be, what, -8? Okay. Technically over 1. We'll deal with that later. Okay, plus, now let's see if I can get this one right. So I'm going to put in 1 first. And if I put in a 1 here, I'm going to get 1/3. And if I put in a 1 here, I'm going to get 1/2. So that's essentially 1/3 plus 1/2, right? So 1/3 plus 1/2. And then if I plug in 0 here, I'll get 0. And if I plug in 0 here, I'll get 0. So I'm just not going to write that. No sense. All right, so then on the left-hand side here, I have positive 8/3. And then on the right-hand side here, I have plus 1/3 and plus 1/2. So here that's 9/3, right, which is 3, plus 1/2, which is 3.5, which is choice D, right? There we go. 27 is asking you for the average value, which means the average value theorem, which I don't know that you guys remember this, but it's the integral from a to b of f of x dx over b minus a. So essentially, we are going to be integrating from -4 to 0 of the cosine of 1/2 x dx, and then that's going to be over b minus a, which is 0 minus -4. Okay, now just be careful. We're not taking an integral of just a plain old regular cosine of x. It's got something else in it, in this case a 1/2, so we're definitely going to have to do u substitution. Okay, let me stop before I say anything else. The answer for 27 is E. So if you got that, then good for you and you can move on. So I'm going to do u substitution. So I know my u is 1/2 x, and then that would mean that my du is going to be 1/2 dx. Okay, so then that being the case, I'm going to need a 1/2 on the inside, which means I'm going to need a 2 on the outside. And don't forget, when we're doing U substitution with bounds, those bounds have to go into the U so that we can create new ones, right? Okay, so I essentially have 2. I'm going to integrate the cosine of U, which I know is sine U. And I'm making new bounds, right? So if I plug in 0 into my 1/2 x, I'm still going to get 0. And if I plug in -4 into my 1/2 x, I'm going to get -2. And then this whole thing is going to be over 4, right? Okay. All right, now I know that, and let me do this in red so you can see it. I'm going to come back to this in a little bit, but we do know that that's 1/2, right? Okay, and I'm going to come back to that in a little bit. I'll explain why. But let's just keep going anyway. So I'm going to go this direction. So obviously, like I said, that turns into 1/2, and then I'm going to be doing the sine of what, 0, right? Minus the sine of, oops, yeah, -2. Okay. All right, well, if I look at this, then I know that the sine of 0 is 0, right? So this is 1/2, actually, times negative sine of 2. So I'm going to put that negative right here, and that'll be -1/2 sine of -2, and there's my answer. And that is correct. However, that's not one of the choices. Okay. Well, I guess you could kind of cheat and you could say, oh, a negative times a negative is a positive. Bing, choice E. Okay, so they want you to find the volume of the solid by revolving the region bounded by the graph of y equals x minus 3, that quantity squared, and the coordinate axes about the x-axis. So let's draw a picture. Well, I know it's a parabola. I know that it's pointing upward. And just don't forget that that -3 inside the parentheses means we're actually shifting to the right 3. When you're inside the parentheses, that's a right shift, or shift to the right, I should say, right? 1, 2, 3. So here's. And so your picture's generally speaking going to look like that. And the volume of the solid formed by revolving the region bound by that graph, and the coordinate axes. So that's both of them. So then the region that they're talking about has to be this one, right? So remember, volume is equal to pi, the integral, and we're going to go from 0 to 3, and it's top curve minus bottom curve. And since we're revolving around the x-axis, you can see that there's no space between the solid and the axis that we're rotating it around. So it's just going to be one radius. So basically pi r squared, right? And my radius is top curve, which is x minus 3, that quantity squared, right? But then we have to square that because, remember, it's pi. Here's my radius squared. So pi r squared, and then dx. And then if you look at your answer choices, that would really be choice B, as in boy. All right, so the answer for number 30 is choice C. So they give you the two equations, and then they want to know what values of x between 0 and pi, that's important, to the graphs of f of x and g of x have parallel tangent lines. Remember, tangent, I associate that with slope, or even more importantly, derivative. So I'm going to take the derivative of f of x. Okay, so f prime of x, and I know that that's secant squared. And then I'm going to take the derivative of g of x, which would be g prime of x, and that's going to be 2x. Okay. All right, so then if you look, I have 3 pictures here, so hold on. So this is the way I plugged it into my calculator. Secant, remember, is 1 over cosine squared, obviously, because that's secant squared. Here's my 2x. Then I went to my window, and if you look at the domain up here, it says from 0 to pi. So my x min is 0, my x max is pi. Okay, I changed my Max a little bit. I went from -4 to 10. It doesn't really matter. But you should get a picture that looks something like this. And basically they want to say, they're looking for where they have parallel tangent lines. Well, these are both derivatives. And we should know the parallel lines have the same slope. So in other words, their derivatives should be equal to each other. So I'm looking for that point right there. So then all you do from there is second calc intersect with your calculator. I'm not going to show you that because I know you know how to do second calc intersect. And when you do that, you're going to get x equals 2.0828. And then when you round that, you'll look at it and see that it's choice C. All right, so that gives you hopefully a really good idea of how to do 16 through 30. Listen, if there's something that you do not understand, please just go back and watch the video again. And if you have to, watch it again. I think that it should make sense, and I think that you'll be fine with it. So this is already typed up on Google Classroom, but your homework for tonight is going to be to do the same sample exam. And I just want you to do 31 to 45. Okay, and then tomorrow I will have a video for you on 31 to 45. Do the very best that you can, please. Do as much of it as you possibly can, and then we will go from there.